In this video, we're going to talk about operations with polynomial expressions. So a polynomial really just means that you have something like x squared plus 3x. Maybe we have a minus root 2. So the exponents all have to be whole numbers, and the coefficients have to be real numbers, and that's a polynomial. Any plain old number all by itself, like this root 2, it could be just a plain old 2, a 3, a 5, 1/2. This is called a constant term, or just a constant. A section of the polynomial that's separated from the other sections with plus or minus is called just a term. And within the term, there's a coefficient, the number part, and a variable. An important concept is like terms. We can add and subtract like terms. We can collect like terms. So like terms, it's very important. A like term has the same variables with the same exponent. The coefficients can be different. The variable has to be the same. So x squared and x are not like terms. Which of these here are like terms? So let's do all of the x squareds in green. So 3x squared, any other x squareds, and 6x squared are like terms. Let's do any xy terms, so x and y each to the power of 1 with pink. Oh, we have an x and a y here, but it's in a different order. It doesn't matter because y times x is equal to x times y. So the order doesn't matter. Okay, and that's it for x, y. Let's do terms that have just an x with an exponent of 1. Let's do terms that have a y squared. Oh, 7xy squared has a y squared, but it also has an x, so it doesn't have the same variable, so not like terms. So that poor 2y squared has no like terms. It's all alone. -5. 0 is a number, just like -5 is a number. There's no variable here, no variable here. They're like terms. 7xy squared has no like terms, and -y has no like terms. So those are like terms. If we want to add some polynomial expressions together, we're going to collect like terms. Some people find it very helpful to circle, underline, anything to indicate which terms are like terms. So let's do that. We have an x squared term here and an x squared term here, so they're going to collect together. 2x squared plus 5x squared is 7x squared. Okay, this xy term, there's no other xy's. Okay, next up there's a constant term, but I still see a variable here, so I like to show my variables first, and it's the only one with just an x. Now let's do the constant terms, the number parts. We have a 4 and a -1. So we didn't really do much with the brackets here, because really in front of this bracket we could write like an invisible 1. It doesn't make a difference if you multiply by 1, so the brackets can just disappear. Same thing here, there's nothing in front, so we can just get rid of the brackets. We have another example here. It's basically the same question, but there's a subtraction. So we don't get the exact same answer because we need to deal with that subtraction. Okay, so that minus is really minus 1 because multiplying by 1 doesn't make a difference. So we have to multiply everything through by minus 1. So 5x becomes minus 5x. Don't need the brackets. Let's get rid of those brackets. Minus negative 2x becomes positive 2x. Minus negative 1 becomes positive 1. Okay, now we can collect our like terms just like before. I forgot a squared. There we go. Okay, so we have like terms here. 2 minus 5, negative 3, x squared. The xy term doesn't have any like terms. The 2x doesn't have any like terms. And we have 4 plus 1 is 5. So notice we got a different answer when we subtracted the polynomials instead of adding the polynomials. Multiply. To multiply polynomials, we really need to understand what multiplication means. So if you had 3 times 2, that's like saying you have 3 groups of 2. 2 plus 2 plus 2. If you have 3a, that's like 3 times a, 3 groups of a plus a plus a. If you have 3 groups of a plus 2, then you have a plus 2, a plus 2, and a plus 2. Now if we collect like terms, we have a plus a plus a, 3 a's, 2 plus 2 plus 2, so we have 6. And notice this is the exact same as what we would have gotten if we just multiplied every term by the 3. 3 times a is 3a, 3 times 2 is 6. So the rule is if we have something multiplying out front, if we have a monomial multiplying out front of a polynomial, we can just distribute it in and multiply it to everything. This works for polynomials. Sometimes people try to do it with exponents. This does not work. If you have an exponent outside the bracket, you can't distribute it in. Okay, so there's an example here, and let's just mark off some of the important things. The 4x gets multiplied in to each term. So 4x times 2xy plus 4x times negative 3y. We have to remember that negative there. You could also have minus 4x times positive 3y. As long as that negative is accounted for, it doesn't really matter how. And then simplify. 4 times 2 is 8, x times x is x squared, and there's no more y's. 4x times negative 3y, 4 times negative 3 is negative 12, x times y is xy. Okay. Now, what if we have 2 binomials multiplying? So binomial means 2 terms, just like bicycle means 2 wheels. So we have 2 binomials multiplying here, and there's a little rule some people know called FOIL. First, outside, inside, last. It just tells you which multiplications to do and in which order. So let's use FOIL to help us make sure we get all 4 multiplications. If you multiply 2 terms by 2 terms, you end up with 4 terms. If you multiply 3 terms by 3 terms, you end up with 9 terms. You might simplify it down and end up with less when it's simplified, but that's the number of multiplications you have to do. And FOIL helps us to remember, otherwise you might only do like 2 multiplications and not get the right final answer. It's very common. Okay, so let's do first. So the first term times the first term gives us 15x squared. Let's do outside. So the outside term and the outside term give us 5x times 4, 20x. do the inside terms. So these ones are on the inside beside each other. 2 times 3x is 6x. (5x) times 4. Oops, we already did that. See? Good thing we have FOIL to help us. We want the last ones. Now, if I would have followed this, I probably wouldn't have had any problems. Last. So last term and last term. 2 times 4 is 8. Okay, now we can simplify because these middle terms here are like terms. 15x squared, 20 plus 6, 26, plus 8. Done. Okay, let's do one more question simplifying. What do you think you need to do first? So here you're going to expand through, and here you're going to expand through. Then we'll have more simplifying to do. So, negative 4xy times 3x. 4 times 3 is 12, so negative 12. X times x is x squared, and then there's y. And multiplied by 1 is just the same thing. That was easier. Minus 3y. Now careful, because this minus has to go through with every multiplication as well. 3y times x squared, so minus 3. Let's do the x's first, because so far we have the x's first. Minus 3y times positive 3x. Minus 3 times 3 is 9. Y times x, xy. Minus 3y times negative 2, positive 6y. Alright, what do we have for like terms that we can collect? There's an x squared y and an x squared y, and an xy and an xy. Okay. 12x squared y minus 3x squared y, negative 15 x squared y, minus 4xy minus 9xy, negative 13xy, and plus 6y. And we're done. Okay, so these are some basics on expanding and simplifying with polynomial equations.